the Sona queue. And what we do is we will do a refresh, and then we will, you can see we refresh over here, right? We reload it, right? If nothing over here as well. As part of the process, right, we'll be doing the code scan using the Sona queue so that the continuous inspection of code quality to perform automatically review with static analytic of code to detect the bug and code smelling. So before that, we were using the Quaker test for this kind of demo, right? And it's pretty much like a hello world of the symbol design of our first application. So the code that we use for this demo will based on the code that we get over here itself, right? The main thing here is that we had to add the Jenkins part line that we have outdated over here, right? Let us look at the Jenkins part line over here, right? We updated the Jenkins part line, and also we require to update this pond.xml file. So if you'd like to look into the Jenkins part line itself, what you will see is a series of different stages that we're going to be using today, right? So if you can see over here, right, that we have defined things like the Git URL that pointing to our GitLab instance. This will be the Git repository that we'll be using it, and we have a different type of stages. So the first stage here will be the build stage, right? And then the second stage we are going to run is the unit test, integration test, followed by this Sona queue analysis. Then we're going to publish the artifact to the Nexus. And then we have the approval stage before we do the deployment using the Ansible tower. So we're calling the function, and this is going to trigger the Ansible tower plugin that has been installed in Jenkins to start the deployment itself. You can see over here that, right, some of the highlighted here, right, I will highlight it here, the extra variable in the Ansible that will be used as part of the deployment workload. So if we are going to other part, right, like let's say we're going to Jenkins website now, right? If you're going to Jenkins website, you were able to see the plugin for this Ansible tower. And with this plugin itself, right, we were able to integrate well between the Jenkins and Ansible tower and help you to deploy the application. Beforehand, right, this is the documentation page that I would like to share with you. That the documentation page basically is cover the configuration, right, the authentication job execution, right, and also some like let's say OAuth authentication and also some job execution over here, right. So now let's us look at this configuration page on this Jenkins integration page, right. And this at this plugin configuration file site, it can show you that you need to configure within the Jenkins in order to use the Ansible tower plugin. The configuration basically is pretty straightforward, right? And very quickly, right, let me walk you through those configuration like Ansible tower, right? Let you look through that, right? There's a plugin that showed you earlier, right? You can see that the password that we key the credential and the URL, right? We just give it a name, and then we do a test connection over here. Once the testing show pass over here and success over here, right, that show you that the Jenkins is able to communicate with Ansible tower using the REST API. And now we look at the Jenkins pipeline. You see that, right, the Sona queue quality gate here is everything is passed, right, and green over here, right, and you can see over here that everything is showing success, right? Server-side processing is success. So the stuff that we're going to do today, right, is we're going to update the applications hello world over here, right, and change it to my hello world. With this, right, we need to update the unit test to my hello world, right, to make sure everything is working properly as well, right? Okay, before I start, right, we also want to make sure that the application at this time is not really deployed on, right? So you see over here that it cannot connect because the application is not yet deployed. If I refresh it, you can see the page is unable to connect, which proves to you that application is yet to deploy, right? So next thing that we need to do is to update the unit test to include the my into the hello world. We normally use the vi or win the file to add the my into it, right? So I add in the my over here now, right, to key in, and then save it accordingly. Then we update the application, the app also using the same method, right? And then once this have done, right, we save it. And then we go to the Git to add, commit, and also do the Git push itself. Once we have done the Git push, it's going to trigger the new build, which we can see the new build is start, right? Let us view the Jenkins stage view here, right? We can see that it's going to start, right? And you can see the logs itself, right? Let us point to the log itself, and it's going to new build of, and everything is good over here when you see that, right? So before we start to do the unit test, right? And when we start the unit test itself, we can also check, right, the log file over here. So everything quite clear and then successful. This come to the integration test, right? Same thing again, we can check the log file, right? And then we can, once it's done, we'll go to SonarQube analysis, right? Now, if it has pushed the nexus, right, we can see from the log file itself, right? We can see that it's already uploading the nexus. And the next step is to waiting for approval. And just want to show you that this has been updated, right, in the unit test, right? Let us share with you here, right? And go to these pages, right? Okay, right? Before we start approval, let's go to this and refresh it, right? The my already added in, right, after refresh. And same thing when we look at the app itself, the word of my is there, right? Then we look at the Maven release and refresh it. You can see that, right? The Java file has been built during the pipeline execution. And then we do a reroute over here to the SonarQube. So you will see the output, right? From the SonarQube perspective, all the conditions are passed and that we cannot see anything that are wrong over here. Everything are good, right? And the next thing that we're going to do is we're going to approve the pipeline, right? So let us go back to this Jenkins stage view pipeline itself, and then we click on the proceeds, right? Once we click on the proceeds, upon approval, right, you will going to trigger the REST API call to Ansible Tower. So we can see that, right, what we're going to happen is we will going to go to the Ansible Tower itself, right, and we can click on the log file and log in, right, using the Ansible username and password, right. Once we log in, we will see the job that run. And basically, it's the application continuous deployment template. You can see the parameter all passed and the log file itself, everything is clear, right. So when we click on the detail by checking the others log file, right, this is the health check log file. So everything is done and endpoint sure that everything is good and working properly, right. When we go back to the Jenkins console output, we can see the application deployment is successful. And the web application, right, is successfully as well. We can see that everything is nicely integrated with this Ansible Tower itself, right. So when we go back to the Ansible Tower now, right, the job itself is similar to what we want when we went to check earlier on, right. If all going back to the stage view, right, so you will see that, right, everything are successful, right. Let's change the screen to this stage view now. You can see that all the in green and the pipeline is successfully finished executed. Then we will come to this application publish website, right? Let me do a refresh, right? You will see here, right? So, ladies and gentlemen, the My Hello World has been successfully deployed, right? So that's the purpose over here, right? The demo itself to demonstrate the Ansible Tower can be used in conjunction with Jenkins in this CD processes, right? So, okay, I really hope you all enjoy watching this video, right? So before I move to the next slide, right, let me conclude with you, right, what we have discussed today. We have discussed about the CI/CD pipeline with Ansible, right? I share with you on how the Ansible playing a role in a CI/CD pipeline and also a video demonstration on it, right? So I wish you all, right, are able to getting some of the basic understanding over today's presentations. So before I end the presentation today, I would like to wish you, right, with you all stay safe, right, stay healthy, and also remember, right, to use Ansible to automate your workload, right? So if you have any other question, right, regarding of today use cases, right, you are welcome to contact your account managers or even though contact us, right, or our marketing team or our sales team or even the solution architect like me, right? So we are welcome you to contact us, right? Either you email us or drop us a call, right? We are more than happy to assist you. So that's all for today. I would like to wish you all stay safe again, right? Remember to use Ansible to automate your workload. Thank you very much. Bye-bye. See you again next year.
Thank you, Mei Yang, for the thought-provoking session. We've reached the last presentation of our technical track, and I'm delighted to welcome Derek Leong, Associate Solutions Architect at Red Hat Singapore. Derek will be covering event-driven automation in the cloud-native era, with a focus on automation architecture powered by Ansible and Knative. Take it away, Derek.
Hi everybody, welcome to this session. My name is Derek, and I'm an Associate Solutions Architect based here in Singapore. Today, we're going to talk about event-driven automation for the cloud with Ansible and Knative. I encourage you guys as well to send in your questions you have in the Q&A box any point of time during this session today. So let's get started. So what is automation like today? In a COVID impact world where there is increased focus on resilience, today there's a lot of disruption to businesses. We're talking about working from home, not being able to go back to offices or attend to systems on the ground. Now, there's a quick shift, right, to digitize and adopt new technologies as well due to all these disruptions. And there's a need for agility, right, being important as well. As teams are working away from each other, how do we ensure that we are still communicating and ensuring overall processes are still optimal today? Now, based on the studies done by IDC, most organizations do share the same sentiment that they will want to be digitally resilient to create new business models, to overall capture market share, as well as support the new operational requirements that have been brought on today in the organization. Now, as they share the same challenges, it's especially so when there are multiple stakeholders that are involved as well. How do we ensure consistency as well as control across all of these stakeholders? Now, that's where we're looking at Ansible automation platform to allow a better holistic automation to unify all the teams together. We want to ensure that from the creation to the consumption is the same and be unified across all the teams. Now, when we look at the different personas, each persona today has different roles and responsibilities, from the domain experts to the business user, where each of these personas generate different set of tasks and set of events, and expect a certain output and action to be taken place as well. So how do we manage that expectation where each persona is generating different set of events? Now that's where we want to incorporate a certain culture to ensure that the teams are working together and are able to handle the changes much more quickly as well. So that's where we're going to look at what serverless or Knative is doing today and working with automation in mind as well. Now let's first talk about serverless. Now serverless is a space that is ever evolving, and we at Red Hat, we are trying to create this evolution at scale. And in order to help our customers understand what is going on, we'll start with the 1.0 phase. And that's when we just started talking about serverless, which for the most part, we just thought about it as functions. So that functions is a small snippet of code running on demand for a short period of time. And technologies like AWS Lambda made this paradigm very popular, but it has its own limitations around execution time, protocols, as well as the overall local development experience as well. Since then, more people realize that the same serverless traits and benefits could be applied to microservices and Linux containers. Now that led us into what I'm calling the 1.5 phase. Now, some solutions here completely abstract the Kubernetes, delivering the serverless experience through an abstraction layer, and that sits on top of it like Knative. Now, Red Hat was one of the founding members of the project and continues to be one of the top contributors on that community. Now, by opening up serverless to containers, users were not limited to function runtimes and can now use any programming language they want. They can also leverage the portability of containers and move workloads around, breaking the lock-in of the cloud providers. But the destination of this journey is when we evolve serverless implementation to handle more complex orchestration and integration patterns, combined with some level of state management. For the most part, serverless means just stateless applications. But many solutions are not being created to help with orchestration, to recreate well-known integration patterns. But when we achieve this 2.0 phase, serverless becomes essentially another feature of your platform. And it becomes a platform as a service, since in practice, most enterprises will be running a combination of serverless and non-serverless workloads. Microservices, monoliths, or functions all running as containers. And that gives our customers the ability to choose the best tool for the job when needed. So when we abstract all these core principles, what we get is the serverless trait that follows that has 6 principles, and these are the following 6 principles. First is we talk about easy to get started. So what we're trying to do is to abstract the complexities of managing or dealing with infrastructure. And next is achieving stateless, meaning that we're trying to delegate the state to services like database or messaging queues, for example, so that you can leave your containers to run at a stateless point of view. Next is scaling on demand, and that's how the application will scale. The more requests you have, the more instances will be provided automatically. Next is distributed and elastic. This allows you to scale easily and according to the demand. And elasticity is key, and this also means that you will run applications today distributed across multiple data centers or cloud providers. Next is being event-driven, which enables applications today to be decoupled and reactive, scaling only when an event happens. And finally, the last core trait, which is the cloud, which allows the application the ability to leverage and benefit from cloud-native principles. Now, 2 key technologies that we are enabling serverless architecture today goes beyond cloud providers, and that are Knative and Cloud Events. Now, let's talk about them a little bit more. Starting with Knative. Knative enables almost any containerized application in Kubernetes to behave serverless. This is possible through the 2 key modules that Knative delivers as extensions to the Kubernetes APIs. Now, first we talk about serving, right? Serving is responsible for the auto-scaling behavior that is based on requests, like an event or an HTTP request. So it's a request-driven model that serves the container with an application and can scale to 0. Now, next will be eventing, and that provides an infrastructure to send and receive events in a standard way, right? A common way of consuming and producing events that will stimulate applications. Now, with all that enables and simplifies the overall user experience for developers. And there's a client called KN that allows you to build serverless applications for Kubernetes without forcing you to write a single line of YAML. Now, looking at what are the differences between building an application in Kubernetes versus building the same application in Knative. We can look at the abstractions required to build applications with Kubernetes, you have to just create at least 3 or 4 different objects in order to have the application auto-scale based on resources and a publicly available URL. Comparatively, Knative offers n single extraction, single object true for your applications called a Knative service. And that is providing the same functionalities from all of these different Kubernetes objects with added benefits to be much more intuitive to read and understand as well. And that targets application developers that just want to run a container and let it all scale based on a number of requests, including the ability to scale to 0 when idle. Now, another key part of this puzzle is the ability to send and receive events. But between all of the different cloud providers and on-premise systems, there is no consistency or portability guarantees. That is why the CNCF Serverless Working Group tackled this problem by collaborating with a number of vendors like Red Hat, Microsoft, SAP, Google, and some end-user companies too, like Nordstrom, PayPal, and others to create cloud events, a specification to describe events in a common way with a common goal. And that enables consistency, accessibility, as well as portability for your cloud-native applications today. Now, one of the main benefits of using the Knative and cloud events to build serverless applications is this ability to offer serverless with extreme flexibility. Now, you can build serverless containers that can receive cloud events or HTTP requests, and you can decide what goes inside of these containers. The ideal thing is to leave your current application, microservices, or monoliths that are containerized today and refactor that container into a serverless container. Or you could choose to create serverless functions, and those functions, they can leverage cloud events or be triggered by HTTP requests. And that makes sure that the programming languages or events that's being used to trigger the application, right? You have to make sure that the standards are common or well understood. Now, there are some benefits for serverless functions being able to utilize out-of-the-box settings for runtime and have some pre-defined programming languages, and that provides you the capabilities to get started easily and handle faster iterations as well. But if the language does not currently have the function runtime yet, you have the option to run and build the application using a serverless container. Now, to piece it all together, you have OpenShift Serverless, which packages and extends Knative with functions, which is installed and managed by an operator. And that provides you the ease of managing day 1 and day 2 operations on any given environment, physical, virtual, public clouds, from UAT to the productions and everything at scale. Now, let's touch on what are the use cases that revolves around serverless automation today. Automation from cloud providers and on-premise solutions. These are usually event-driven in nature, but they lack the destination, lacking the ability to send those events, and from those events, trigger a series of actions. So now, looking at this diagram, we have the cloud and on-premise systems today that generate those events, but you need some mechanisms or infrastructure that is able to consume those events and execute those actions as well. Now, that is where we see Knative and Ansible as a key pairing to achieve that end goal. Taking this example, we are looking at a scenario where an event is being triggered. It could be an incident ticket, monitoring alarm, service threat, the security threat, and after that event is being triggered, we see the automation tool kicking off the automation workflow to produce that remediation. Now, with this workflow, after the event has been triggered, either through events or by the users, Ansible automation platform will leverage on execution environments that are run as a container today, and that allows the container orchestration platforms like OpenShift to consume these containers. And with that change to execute tasks as a container, it allows the execution environments to be built with the relevant dependencies to be executed across different use cases and domains. Now, that allows you to effectively manage and scale out much more easily as well. Now with that, we are able to create many use cases around it. Like for example, when you trigger things like a workflow that entails ticket creation for VM deletion or removal, or even triggering a request for new storage capacity if it drops a certain threshold. There are many ways and many ideas that can come from event-driven automation, and it's limitless as well, and can be customized very easily. Now with that, another use case is to be able to do things like schedule tasks in a cloud-native way, and that uses containers to define tasks for schedule execution. Use cases like fact collection or config management, baseline scanning are some examples of how you can trigger Ansible automation platform and utilize scheduled tasks to execute across multiple different environments today. One of the key parts is to have these event sources and to connect with cloud or on-premise systems to your application. Now, this is why OpenShift Serverless, which is based on Knative, today it comes with a set of runtimes, and that allows you to translate and connect to all these different systems. So OpenShift Serverless today, which is based on Knative, it has a set of runtimes and a set of event sources, and that allows you to trigger, to connect to different systems and trigger different applications. Now, we are definitely working very closely with a number of partners to increase the number of event sources as well. And we work very closely as well with our own Red Hat integration suite, and is able to augment all these event sources. Now, to show some example snippets of YAML templates, here you have a cloud event or HTTP request that runs the Ansible playbook, which is packaged within OpenShift, within Knative, and the task run will then trigger all the necessary APIs in a given cloud or multiple clouds to perform the use cases that has been predefined in the playbook. Now, to conclude. So what can we do next? So what we want to bring is to bring forth the value of Ansible automation platform to you. And we want to evaluate your savings to show you not only in dollars, but also in time as well. How do you save time as well? We also want to enable you with the knowledge and the possible ways to get started on all these platforms itself. And lastly, we want to work closely with you on the automation journey from whether you are from starting out or you are already towards the end. Right? We want to be there with you, working with you throughout your journey as well. Now, when we talk about the value of automation, what does event-driven automation benefits bring? So when we talk about the different savings earlier, talk about savings in dollars, we not just want to talk about the reduction of operational costs, we also want to talk about how we can improve the time to market as well as time savings in terms of how you're doing things today. Right? We talk about how we can to achieve extensibility, right? Providing flexibility and control of your infrastructure itself. Next is having continuous improvement that facilitates the overall feedback loop of how event-driven is able to give you that feedback loop and do things like prevent prior incidents as well. Next is how are we able to design automation at scale, right? How are you able to utilize automation to scale your infrastructure horizontally, scale your applications as well, and how are we able to utilize self-service and provide an overall control and compliance across your organizations itself. Now with that, you may find more valuable sources for Knative as well as serverless in these links. For Red Hat OpenShift Serverless, you can head to that link. And if you want to learn more about automation and server automation platform, you can head to that link as well to learn more about what we are offering today. Now, besides those links that I've shown just now, you can as well increase your knowledge on purchasing the single subscription we have for our learning courses. So at Red Hat, with a single subscription, we are able to provide a myriad of learning courses that enables you to increase your know-how. So starting with the basics, we have the basic Linux administration course, and that gives you the fundamental level of how you're going to manage Linux systems today. And with that, how are you going to increase with Linux with Ansible? And that will be the Red Hat Certified Engineer exam. That gives you the knowledge on how are you going to use Ansible with Linux today to manage things like basic configurations of Linux, as well as managing Linux systems today with Ansible. Now moving on to the proficient level, that's where you're going to talk about Ansible best practices, and the things that you're going to learn are things like managing Git repositories for playbooks, how you're going to manage the playbook tree structures, and what are the key Ansible concepts to create a much more readable playbooks, and what are best practices as well. We also have network automation that's within that proficient level, as well as other domains of automation as well. Lastly, we have the extension to the Ansible specialist track to enable you with Ansible with Python, as well as being more specialized in understanding how modules or collections today are being written in Python. We have the advanced phase as well, where you're going to learn about how we manage DevOps, right? How are you going to incorporate your DevOps workflow, things like Git and test-driven development, as well as the CI/CD development today with Jenkins. And with that, I thank all of you for attending this session today. If you have any questions, do leave it in the Q&A box, and we will answer them shortly as well. Again, thank you very much, and have a great day ahead. Take care.
Wow, what an amazing session to close the event. Thank you to all our brilliant speakers and to you, our guests, for gracing this year's Red Hat Ansible Automates virtual event. Your participation, whether with the speaker Q&A and the quizzes, or just by attending the sessions, has made today a great success. We do have one last ask for you. We'd love to hear your feedback. Let us know your thoughts by scanning the QR code on the screen or clicking on the feedback form link in the Q&A widget. Looking forward to seeing you again soon in person. Till then, from all of us at Red Hat, stay safe and have a great day ahead, and keep on automating.